Hello everyone, welcome to my channel Lifescience with Nivedita. So this is KSET Lifescience 2023 most important topics discussion series. So I already made a playlist of this video series. I provide link in the description, kindly check it out. So in today's video, we are going to discuss about one of the most important topic, that is human genetic disorder affecting amino acid catabolism. Okay, so usually inside our body metabolism has to be takes place, right? So that is nothing but what? Some molecules, that is biomolecules, has to anabolize, catabolize. So it has to break down, it has to form for the production of some sort of ATP, that is some sort of energy. Okay, so here just similar like carbohydrates, nucleic acids, amino acids also catabolize. There are 20 standard amino acids are there. So all 20 standard amino acids has to break down, and which will act as intermediate to some metabolic pathways. Then it will involve in the metabolic process. Okay, so here for the metabolisms, usually we can say it is a bridge. What is that? That is enzyme will act as a bridge for the metabolic process. So if any enzymes will get deficient, that will leads to some disorder. Okay, that's what we discussed in today's video. Okay, so here you can see disorder, that is amino acid catabolism disorder, defective process. Okay, so then defective enzyme, so which enzyme will defect, and also its effects. Okay, so one by one we discuss now. So first of all, the first disorder is what? That is albinism. Okay, the first one is albinism. So albinism defective process means what? That is melanin synthesis from tyrosine. So usually, melanin is a skin pigment, right? So when this melanin synthesis from tyrosine will get defect, there is no synthesis of melanin. So that leads to what? That is albinism. Okay, so for the production of any molecule, anything, an enzyme is required. Okay, so here which enzyme is defect? That is tyrosine 3 monooxygenase, or else we can call it as a tyrosinase. Okay, for the melanin synthesis, tyrosine 3 monooxygenase enzyme is required. So when this enzyme is get deficient, that will leads to albinism. Anyhow, albinism means what? That is lack of pigmentation. There is no pigment. When there is no melanin means what? There is no pigment. That is white hair, pink skin. Usually, Western country people are very prone to this melanin. Why? Because they have very less melanin content. Because of this less melanin content, their hairs are white, and also their skin are very pink in color. Okay, so the first disorder is what? That is albinism. And defective process, that is tyrosine is responsible for the synthesis of melanin. So why tyrosine is not synthesized? Because of the defect of this enzyme. Which enzyme? Tyrosine 3 monooxygenase, or else tyrosinase. And the effects are lack of pigmentation, that is white hair and also pink skin. So African peoples are having very high melanin content. Okay, so if the person is in black in color, that means what? That person is having very high melanin pigment. Okay, so the next disorder, that is alkaptonuria. So alkaptonuria also one of the amino acid catabolism disorder. So the defective process is what? That is tyrosine degradation. Okay, so tyrosine degradation will get defect in this alkaptonuria disorder. So here the defective enzyme is what? That is homogentisate 1,2 dioxygenase. Okay, because of the defect is nothing but what? Absence. Okay, because of the absence or any defect of this enzyme, which one? Homogentisate 1,2 dioxygenase, there is no tyrosine degradation. When there is no tyrosine degradation, alkaptonuria disorder will take place. And when come to the effects of this alkaptonuria, that is dark pigment in urine usually dark in color. Next, late developing arthritis will develop. Okay, so this is about alkaptonuria disorder. Okay, and the next disorder, that is arginemia. Okay, so this arginemia is a defective process of urea synthesis. Okay, for urea urea synthesis, amino acids are involved. This one is arginine also involved in the urea synthesis. So here, when arginemia will occur when there is a defect in the urea synthesis, and here which enzyme is defect? That is arginase enzyme will get defect. When there is a defect of this arginase enzyme, which will affect the urea synthesis, that will leads to arginemia. Okay, and when come to the effects of this arginemia is what? That is mental retardation, which will affect the brain. Okay, and the next disorder, okay, one second, okay, so the next disorder is what? That is arginosuccinate, one second, yeah. So the next disorder, that is arginosuccinic acidemia. So one second. Yeah. The next disorder which will affect from this amino acid catabolism, that is arginosuccinic acidemia. Okay, so here also the defective process is urea synthesis, and the defective enzyme is what? That is arginosuccinate lyase. So when this arginosuccinate lyase enzyme will get deficient, that will leads to arginosuccinic acidemia. Okay, and when come to the effects, that is vomiting and also convulsions. Convulsions means the irregular movement of muscles. Okay, that's what called as convulsions, or something like that, tiredness. Okay, so arginosuccinic acidemia disorder will takes place when this arginosuccinate lyase enzyme will get deficient. Okay, so the next disorder, that is, yeah, carbamyl phosphate synthetase 1 deficiency. Sorry. Carbamyl phosphate synthetase 1 deficiency disorder. So here the defective process, here also urea synthesis will get defect, and when come to the enzyme, that is carbamyl phosphate synthetase 1, this is the first step in the urea cycle. Okay, so carbamyl phosphate synthetase 1 enzyme, which is responsible for this first step in the urea cycle. So when this enzyme will get deficient, that will leads to carbamyl phosphate synthetase 1 deficiency. And when come to the effects, that is lethargy, convulsions, and also early death. So these are the effects of this disorder. And next, when come to the another disorder, okay, yeah. So the next disorder from this amino acid catabolism, that is homocystinuria. Okay, so it's homocystinuria disorder. The defective process is methionine degradation. Anyhow, I already mentioned every amino acid has to degrade, and when it is degraded, it has to act as intermediate to some other metabolic pathways like Krebs cycle, HMP pathway, glycolysis, urea cycle, whatever. Okay, so here the defective enzyme, that is cystathionine beta synthase. So when this enzyme will get deficient, that will leads to homocystinuria. So here which will degrade? Methionine degradation will degrade with the help of this, when this enzyme will get defect. So when come to the effects, that is faulty bone development, then mental retardation. So these are effects when come to this homocystinuria disorder. So next disorder, that is maple syrup urine disease. Okay, so here the defective process is isoleucine leucine valine degradation. So these three enzymes are not get degraded. So because of this thing, what happened? The maple syrup urine disease will take place. So which enzyme is deficient here? That is branched chain alpha keto acid dehydrogenase complex. So this enzyme will get deficient, that will leads to maple syrup urine disease. Okay, so the effects are vomiting, convulsion, mental retardation, and also early death. Okay, so next move on to the next disorder. So that is methyl melanoic acidemia. Okay, so the next disorder, that is methyl melanoic acidemia. So here the defective process is what? That is conversion of propionyl CoA to succinyl CoA. Okay, so this process will get defect, and the enzyme which is responsible for this deficiency, that is methyl melanin CoA, mutase. So when this methylmelanin CoA mutase enzyme will get deficient, that will lead to defect in the process of conversion of propionyl CoA to succinyl CoA, that will lead to methylmalonic acidemia. Okay, so when come to the effect, just similar like above thing, that is vomiting, convulsions, and also mental retardation as well as early death. Okay, so next, the last but not the least, the last disorder of this amino acid catabolism, that is phenylketonuria. Very similar, familiar disorder. So here the defective process is what, that is conversion of phenylalanine to tyrosine. Anyhow, every amino acid has to convert into some other thing for the degradation. So here what happened, the conversion of phenylalanine to tyrosine will get defect because of the deficiency of some enzyme. So the deficient enzyme is what, that is phenylalanine hydroxylase. So this enzyme will get deficient, which will give rise to effect in the process of conversion of phenylalanine to tyrosine. And when come to the effects, that is neonatal vomiting and also mental retardation. Okay, so this is about amino acid catabolism disorders. So every disorder is very important. Just go through the slides here. The most important thing is defective enzyme as well as defective process. Just go through the enzyme as well as disorder. I think this is more than enough. Okay, if any doubts, let me know in the comment box, and give me one like to this video. Okay, all the very best. Okay, so boost your preparation. So thank you.